Hello everybody, today we'll be talking on the equation of motion, and these are the equation of motion on the board. The first one is V is equal to U plus AT. The second one is S is equal to UT plus half AT square, and the third one is V square is equal to U square plus 2AS. So this V here is our final velocity. The V is our final velocity. The U is our initial velocity, the A is the acceleration, the T is the time taken, and this S here is our distance covered. So I'll be showing us one by one how we get about this formula. So let me start. From our definition of acceleration, we know that acceleration is change in velocity over time taken. Acceleration is change in velocity over time taken. That is final velocity minus initial velocity over time. So we have V minus U is equal to 80. And then when we make V the sort of formula, we have V is equal to U plus 80. So this is the first equation of motion. So you see V is equal to U plus 80. This is how V is equal to U plus 80 is being derived. So let me quickly do the second one too. Second one. From the second one is S is equal to UT plus half AT square. And then from our knowledge of average speed, we know that average distance, or let me call it distance, I'm sorry. Let me call it distance is equal to average speed times time. So distance is average speed times time. So I will just write that S, the symbol of distance is S, and this average speed. That's the final initial velocity plus the final velocity divided by 2, then times our T. And then if you notice something, in our equation 1, we have V is equal to U plus 80. So what we are going to do is that this V that is here, we are going to slot it into this equation. So wherever we see V, we are going to put U plus 80 there. So look at it. So we have 1 over 2 U plus. So instead of us to write V like this, we write U plus 80 times time. So what are we left with? We are left with half. So we now have 2U plus 80 times time. I hope you understand. We are just doing slotting of the symbol here. So we have this now. So how do we go about this now? So let us do it like this. So the next we now have S is equal to half. So we have, because 2U times T will be 2UT plus 80 squared. So when we now open the bracket, we have times 2UT plus half 80 squared. S is equal to half times 2UT plus half 80 squared. So what next are we going to do like this? Very simple. So we have these 2 here, we cancel these 2 here. And what we have next is S is equal to UT plus half 80 squared. This is our second equation of motion. This is how we derive this. So second equation of motion. And then for the third equation of motion, we know that A is equal to V minus we know that A is equal to V minus U over T. A is equal to V minus U over T. And when we make T this sort of formula, T will be equal to V minus U over A. And then we are now going to use the formula of the distance covered that we use in equation 2. That is S is equal to half U plus V times T. Times T. So that means this one we can also write like that, U plus V over 2. Our time now, wherever we see T now, we are going to slot this thing there, V minus U over A. We will have V minus U over A. So S is equal to U plus V over 2, then V minus U over A. So this is what we are left with. So the next thing is, let us open this bracket. So U times V is UV. So we have UV minus U square plus V square minus UV over 2A. So if you now notice something, that this one is a positive and this one is negative, so we can cancel this and this. So what we are left with is S is equal to V square minus U square over 2A. S is equal to V square minus U square over 2A. So if we want to make V square the sort of formula, so we have V square minus U square is equal to 2AS. So V square is equal to U, let me write the V very well so that I don't mistake it. V square is equal to U square plus 2AS. So this is the third equation of motion. This is it over here. V square is equal to U square plus 2AS. That's the third equation of motion. And then there are things that we have to note, because in our subsequent lecture we'll be doing a lot of calculation on motion. You have to notice that when the body starts from rest, the initial velocity is equal to 0. When the body is starting from rest, the initial velocity is equal to 0. And when the body is stopping, when the body stops, maybe when brake are applied or when retardation occurs, that they come to rest, or the body stop or come to rest, the final velocity is equal to 0. And when the body is moving at a constant velocity, the acceleration is equal to 0. So these are the things that we should know now before we move to the next level on the equation of motion. Because we still have the calculation and the velocity time graph to take note of. So let's call it a day for today. And please don't let us forget to like, subscribe, and share. Have a wonderful day.